collisions per unit time, which is called collision frequency, that is calculated for a reaction. Z is equal to pi into sigma square AB root 8 kT by pi mu into Na into Nb. So here sigma AB is collision diameter. Sigma AB. This is equal to collision diameter. Okay. And mu is reduced mass. Okay. Then we can also calculate the fraction of fruitful collisions. So fraction of fruitful collisions. So that is K by A, that is equal to e to the power minus EA by RT. Or we can write K is equal to A into e to the power minus EA by RT. Okay. Here K is specific rate. And A is called frequency factor, which is also called as Arrhenius factor. A, frequency factor or Arrhenius factor. Okay. So from all this data we can calculate the collision frequency and also fraction of fruitful collisions. Okay. Collision frequency indicated with Z, and that is given this formula pi sigma square AB root 8 kT by pi mu Na into Nb. Whereas fraction of fruitful collisions, that is given as K by A is equal to e to the power minus EA by RT, and this can be written as K is equal to A into e to the power minus EA by RT, where K is specific rate and A is Arrhenius factor or frequency factor. And EA, you know about EA. EA is activation energy. Then R is universal gas constant and T is temperature. Okay. Then energy of activation. So that is a, then coming to significance of activation energy. So activation energy, it depends upon the nature of the reaction. So EA, activation energy, depends on nature of reaction. Okay. And it is independent of concentration and pressure. So depends upon the nature of the reaction and independent of concentration and pressure. So here activation energy depends upon the nature of the reaction. For example, if we consider two important chemical reactions which may take place in all the chemical reactions, which are exothermic reactions and endothermic reactions. Okay. So coming to significance of activation energy in these two types of reactions. One is exothermic and another one is endothermic reaction. Okay. If activation energy of reaction is less than that of the backward reaction, so that reaction is called as exothermic reaction. Okay. So activation energy of forward reaction is less than that of the backward reaction. Okay. So that reaction is exothermic reaction. So that is basing upon the activation energy. Okay. For example, if we consider a reversible reaction, so two reactions are involved in that, forward reaction and backward reaction. So if activation energy of forward reaction is less than that of the backward reaction, and the reaction is called exothermic reaction. So if activation energy of forward reaction is less than activation energy of backward reaction. Here F indicates forward reaction and B indicates backward reaction. And the reaction is called exothermic reaction. Okay. If it is greater than that of backward reaction, that is endothermic reaction. Okay. Reaction is endothermic reaction. Greater than the backward reaction, endothermic reaction. Okay. So from this we can write activation energy of forward reaction. So that is equal to delta H plus activation energy of backward reaction. Okay. And activation energy of backward reaction, this is equal to activation energy of forward reaction minus delta H. Okay. So this is the general formula what we use, okay, to predict the reaction. So total enthalpy change of the reaction, delta H. Delta H is equal to activation energy of forward reaction minus activation energy of backward reaction. So heat of reaction, delta H, heat of reaction, which is indicated with delta H, this is equal to activation energy of forward reaction minus activation energy of backward reaction. Okay. So for exothermic and endothermic reactions, delta H for exothermic reaction, that is negative. Okay. And delta H for endothermic reactions, that is positive. Okay. So this by using activation, and this is the main significance to predict two different reactions, exothermic reaction and endothermic reaction. Where in exothermic reaction, activation energy of forward reaction is less than that of backward reaction, that is exothermic reaction, where delta H is negative. And in endothermic reaction, activation energy of forward reaction is greater than that of the backward reaction, where delta H is positive. Okay. And these are the some important formulas. Net enthalpy delta H is equal to activation energy of forward reaction minus activation energy of backward reaction, where activation energy of forward reaction is enthalpy plus activation energy of backward reaction, and activation energy of backward reaction is equal to activation energy of forward reaction minus delta H. Okay. Next, coming to proper orientation of the reaction. Okay. Orientation of the reaction. To occur the chemical reaction and reactants with fruitful collisions to convert into products, another factor is also necessary, which is called probability or steric factor. Okay. So P is equal to Z into e to the power minus Ea by RT. Okay. So in collision theory, both activation energy Ea and probability factor, which indicates the proper orientation. So they determine the effective collisions. Okay. So if orientation is in the proper way, so proper collisions takes place between the reactant molecules, then only we get the final products. If collisions are not in the proper orientation, if improper collisions are there, we cannot get the final products. For example, here if we take reaction between hydrogen and iodine, we get hydrogen iodide, two molecules of hydrogen iodide. 1 mole of H2 gets reacts with 1 mole of iodine, and we get 2 moles of hydrogen iodide. If proper collisions takes place here, H2 molecule interact with the I2. Okay. So molecules both approach nearer. Okay. With the proper orientation. A new bond is formed between hydrogen and iodine. So we get 2 moles of hydrogen iodide. So this is proper orientation. okay, which depends upon the activation energy and also P factor. Then if improper collisions are there, hydrogen and iodine both approach together like this, okay, instead of bond formation, here molecular separation takes place, okay. So molecules get separated again as H2 and I2. So there are no final products here, okay. Same reactance occurs again here, okay, molecular separation. So that's why for proper orientation, two factors are necessary. One is activation energy and another one is orientation factor, probability factor. That's all.